In this video, we're going to be looking at how to solve linear inequalities. So before we get started, there is only two rules that you need to be aware of when solving linear inequalities. So let's have a look at an example like x minus 5 is greater than 8. So if we wanted to solve an inequality like this, we simply ignore the inequality and just pretend like it's an equal sign. So if we solve any linear equation with an equal sign like this, we know that we just have to add 5 to both sides. And if we get that, we get x equals to 13. However, we only pretend like it's an equal sign. We don't actually change the sign to an equals. So we say that x is more than 13. And we can check our answer by simply picking a random number that's more than 13. I'm going to pick 15. So if I do 15 minus 5, that is indeed more than 8, since 15 minus 5 is 10, which is more than 8. So that's how you solve an inequality 99% of the time. However, there are two exceptions to this rule. And the first exception is when you're multiplying or dividing by a negative number. So let's have a look at an example when this is the case. Let's say we take the example x is greater than, or minus x is greater than 6. The first step I said to do was to pretend like this was an equal sign. So if I pretend this is an equal sign, all I can do is times both sides by -1 to get rid of the negative. And so what I'm left with is x is more than -6. Everything seems all good, but let's simply pick a number that's more than -6. I'm just going to pick 0. So if I do -0 is greater than 6, i.e. 0 is greater than 6, this is simply not true. 0 is not more than 6. So in a case where we times or divide by a negative number, which is what I did, I times both sides by -1. If that happens, you simply have to flip the inequality. So because here it says greater than, I'm just going to flip it to less than. So now this statement is correct. So that is the first scenario by which I have to flip the sign. The second scenario in which I have to flip the sign is when I'm doing a reciprocal. So let's take an example like this. So let's take an example like this. 3 divided by x is less than 2 over 5. So again, let's just pretend like we're solving this as though it's a normal equation with an equal sign, pretending it's equals. So what I would do in this situation is I would take the reciprocal of both sides. And another way of saying taking the reciprocal of both sides is doing to the power of -1. But in this case, I'm just going to take the reciprocal. So when I do this, I get x over 3 is less than 5 over 2. So then what I would do is I would take both sides and times it by 3. And all I would do that for is to get rid of this 3 here. So then I have x is less than 15 over 2. So let's pick a random number less than 15 over 2. And just to make life easy, I'm just going to pick a number like 1. So let's go back up here. If we plug 1 into this equation, let's check if it's true. 3 over 1 is less than 2 over 5. Well, I know 3 over 1 is 3, and 2 over 5 is 0.4. That's not correct. That's because this is also another exception to the rule. Whenever we take the reciprocal, like we did in this step over here, we have to change the sign. So from less than to now greater than. And that also carries down to this line here. So those are your two exceptions to whenever you solve a linear inequality. This is our first example. Go ahead and pause the video and try this yourself before I work through it. Okay, so whenever we solve an inequality, we always treat it like an equal sign. Always treat it like it's equals here, only if we come across those two exceptions where we have to either multiply or divide both sides by a negative number, or we have to take the reciprocal of either side. So let's try and see if we have to even come across those two exceptions. So the first thing I'm going to do is I'm going to times both sides by 3 over 2. And if you're confused as to why I'm doing this, I have another video on my channel where I solve linear equations. So just search on YouTube, Sir explains solving linear equations, and you should get that video as to how to solve an equation like this, where it's an equals. So we're timesing by 3 on 2, and that simply gets rid of this fraction term at the start. So if I continue, I'm going to have 2x take 5 is less than 2 times 3 over 2, which is just 3. Now I can minus 5 from both sides, or I mean I can get rid of this minus 5 on this side by simply adding 5 to both sides. And so what I'll have left is 2x less than 8. And if I keep going, I can divide both sides by 2. And I'll be left with x is less than 4. And this is my answer to the question. X is less than 4. Since I didn't come across those two exceptions, I can just leave my answer like this. Now have a go at this question here. Pause the video and give it your attempts. So the way I would solve this question is I would first expand the brackets. There are many ways to solve it, but I prefer to expand. So I would expand by saying a half x plus 1 minus x is greater than 1. And I can simplify this by combining the x terms. So a half x minus 1x is the same as minus a half x plus 1 is greater than 1. Now I can actually get to solving the equation. I can get rid of this plus 1 over here by simply minusing 1 from both sides. And if I do that, I'll be left with minus a half x is greater than 0. And if I wanted to get rid of this minus a half, I'm simply going to times both sides by minus 2. And so what I'll have left is I'll have that x is greater than 0. However, because I had to times by a negative number, that means my final answer's sign is actually going to be switched. Because it's greater than here, it's going to be less than over here. And so that's how you solve this equation over here. This will be our second last example for the day. Pause the video and give it a go. So the first thing I'm going to do is I'm going to rearrange so I get the minus 2 over to the other side. So because we're dividing, the opposite is timesing. I'm going to times both sides by minus 2. And what I'll have next is 1 minus 7x is greater than or equal to minus 20. However, since I times by a minus number, you guessed it, we have to flip the sign from greater than to less than. Now I can keep going. I can move this 1 to the other side by simply doing minus on both sides. So I'll have minus 7x is less than or equal to minus 21. And lastly, I can divide both sides by negative 7. And because I'm dividing by a negative number, I have to flip the inequality back to greater than. And because minus 21 or minus 7 is 3, our answer is x is more than 3. This will be our last example for the day. Pause the video and give it a go. Okay, so whenever we have two really annoying fractions on one side, I'm simply going to take the effort and merge them into one, just so my life becomes easy in the next step. So if I want to make these two fractions into one, I have to times the numerator and the denominator of the second fraction by 2. That way when we're minusing away two fractions, their bases will be the same. So what I have now is 3x minus 1 over 4 minus 4x plus 6 over 4. And now, because I can merge the two fractions together, I can have 3x minus 1 minus 4x minus 6 all over 4. And that is less than minus 2. Now what I can do is I can times both sides by 4, and before that actually I can simplify the numerator. So I can simplify the numerator by making 3x minus 4x equal to minus x, and then I can do minus 1 minus 6 is the same as minus 7 all over 4. To get rid of the 4 on the bottom, I can times both sides by 4. And so if I do this, I'll have minus x minus 7 is greater than minus 8, less than, my apologies. And to move the minus 7 across, I can add 7 to both sides. So I'm just taking the opposites of whatever operation is already there. And so that would simply come out to minus x is less than minus 1. And if I want to get rid of the negative, I can either times or divide by negative 1. And because I'm timesing by a negative number, you guessed it, I have to flip the inequality. So x is greater than 1. That's how you solve linear inequalities.